Now we'll be discussing about control subsystems. Okay, so in control subsystems, when we talk about control subsystems, we have to talk about two things. One is hardware, one is about software. Hardware for running the program or running the algorithm, and software itself is an algorithm or program. Okay, so here we can see what kind of control program or control software can be inside a robot. Okay, one is robot vision, that means to see something, to identify something, okay, recognize something. Second, PID control for taking the decision on left right movement, okay, or to reach a goal. Third one is trajectory or motion planning, that means how to reach a start position to a ending position, which algorithm it is going to use. It's like kind of PID algorithm, but there are different type of standard algorithms for taking the for identifying the trajectory or for identifying the motions. Like trajectory is commonly used for space activities, like when one rocket goes to moon or Mars, it has a trajectory, which path it's going to follow. Okay, so this word is commonly used for that kind of autonomous robot, autonomous rocket. But in our robotics, also we use this word for going from one place to another place. Then the localization, where am I? Where is the robot? Okay, from where to go? Okay, so that is also another important part, localization. Then manipulator control, like for reaching one point, which motor need to move in which degree. Okay, that is very, very important. So manipulator or control the manipulator, we need to use a control software. Then UAV navigation, of course we know, unmanned aerial vehicle for running an unmanned aerial vehicle. If it's a quadcopter, that means it has four motors, which motor will rotation in which speed, for which direction, that is very important, and for which height, that is very important, or for only one wheeler or two wheeler rover. Okay, this is the wind direction, that means the propeller, the speed of the propeller is important. Then sensor calibration and sensor fusion. Sensor calibration means all the sensor doesn't work in the same way, so we need to calibrate a sensor. In our sensor part, some of our colleagues, they will discuss about what is calibration, sensor calibration, but keep in your mind, that means to understand the sensing, like LDR. LDR gives us what? The resistance. But our system doesn't understand the resistance. It understands only 0 and 1. So by using a circuit, it's giving current from resistance to converting resistance to current. Then another ADC, yes, ADC is used for analog to digital conversion. Okay, then our control system is identifying for which light or which amount of light, what will be the number. That is the calibration. Okay, in the same way, for which sound level, what will be our number. Okay, so from analog values to digital, digital value, we need to have some calibration. So calibration software is another very important software of the control system. Then kinematics and dynamics, like for moving our hand, we need to make some kinematics and dynamics algorithm. Then the interfacing, like to interface one sensor with another device or one device to another device, we need interfacing, okay, and of course communication. Okay, so these are the control softwares, types of control softwares we mainly used in our robotics. Now these are the types of control hardware. There are different type of processing elements, okay, are in the current world. So these are the type of that. One is microcontroller, then the Arduino, then the PLC, then the FPGA, then the single board computer, portable PC, and cloud computing system. Okay, let's take a look about microcontroller. Microcontroller is a very small size, very cheap processing element where all the components of a computer is available. Like when we draw a computer, first we draw a CPU where registers, ALU, control units are available. Then we need primary memory like RAM and ROM. Then also, input unit can communicate with our computer, and output unit can be used on a computer, and we can also have some secondary storage. Okay, and also we can have some communication. Okay, a microcontroller actually having all these things together. But you see, we used a partial part, not the whole part. That means a part of I/O can be inside the microcontroller, like ADC is built in with the microcontroller. We can directly interface a switch with the microcontroller. We can directly glow a LED by using microcontroller. Okay, we can directly run a servo motor by using microcontroller. So a part of, that means the interfacing part of I/O device is included in the microcontroller. Not all the interfacing, but partial interfacing part of I/O devices are included in the microcontroller. In the same way, it doesn't have the huge secondary storage, but yes, of course, it has some memory inside the microcontroller. It doesn't have the all communication medium, but at least there are TX and RX that can to communicate with the external devices. Okay, so the whole thing of a computing system is a microcontroller. Okay, so this is very cheap, but the problem is the speed is very low. The amount of secondary storage is very low. The RAM is very weak. The communication, it doesn't have an extensive Wi-Fi communication. It doesn't have RJ45, but it has SPI or I2C communication. Okay, it doesn't have USB I/O devices, but it can have some low-level I/O devices. Okay, it can control some motors, it can control some, it can glow some LEDs, or it can take input from some sensors, it can take some input from some switches like these. Okay, so it doesn't have the whole I/O things or high-level I/O things, but yes, it has very low-level I/O operation. Okay, we can do some low-level I/O operation. So what is the application of this microcontroller? We can use this microcontroller in our control system, like for controlling our air conditioner, for implementing our remote control, or this kind of presenter. Okay, for this kind of, where we just use few keys to make something, to control something, we can use this kind of microcontroller. Very low cost. Okay, the price starts from 50 taka to 2000 to 3000 taka. Okay, yeah, we can make some industrial product. Okay, by using a microcontroller, we can use industrial product. Okay, like here, there is microcontroller inside this. Okay, if we'll dismantle your calculator, you can find a microcontroller over there. If we'll dismantle some remote control, you can find a microcontroller over there. Okay, so it's commonly used in our control system to control our devices, smart devices and IoT devices. Okay, but the problem is it's difficult to program. Okay, you can find microcontroller inside your microwave. Okay, in your refrigerator, everywhere you can find the microcontrollers. So, but the problem is the processing power is very low, as I told you. Okay, and also it's complicated to program it. Okay, you need a special programmer or burner unit to program the microcontroller. Then you will take it to the original device and for R&D or for checking whether it's working properly or not. So this process is not so easy. Okay, so for R&D, this is not a good idea. For R&D, this type of Arduino is a very, very good idea. Okay, in Arduino, it actually uses the microcontroller. you can see in the central part, this is a microcontroller. Okay, so it uses the microcontroller, but it has some trainer board. It has some ports, I/O ports, some communication ports dedicated for this thing, and you can easily interface a motor. You can easily interface some LED. You can easily interface some communication modules very easily here. Okay, so that's why Arduino can be used for R&D. When R&D is finished, then you can use the same program with the microcontroller and you can use it in our industrial item. Okay, so for Arduino, for R&D, Arduino is a good choice. Okay, but for R&D, microcontroller is not a good choice. But again, as I told you, both are the same thing. The same microcontroller is using in Arduino, but there are a number of types of Arduino, depends on our application. Okay, so if we use a very small robot, then we can use a very small Arduino. There are Arduino Nano, Uno, okay, Arduino Mini. Okay, there are small size Arduino or there are big size Arduino, depend on our choice. Okay, and yes, this is another thing, programmable logic controller. Okay, these are heavy duty control device. Okay, microcontroller or Arduino can control things, we can program it, but these are not heavy duty, not 24 hours a day, 7 days a week. No, you cannot use Arduino or microcontroller for such heavy duty item. For such heavy duty item, you can use PLC. Okay, programmable logic controller. It is similar to Arduino, the same thing. It don't have very high powerful computing system. It doesn't have too much memory. It cannot interface with a number of I/O devices. It doesn't have so many communication protocol. It doesn't support so many communication protocol or communication medium. But yes, it is a heavy duty item. Okay, when you want to use something, some machine, which machine will run 24 hours a day, 7 days a week, okay, 52 weeks a year. For that kind of machine, or in the very rough environment, okay, in the sunlight or even in the rain, okay, in that kind of purpose where the temperature fluctuates a lot, in that circumstances, PLC can be a good choice. Okay, and now FPGA. FPGA is field programmable gate array. This is a chip where you can build your own digital logic circuit. Once again, this is a chip where you can design and implement your own chip. You can build your own processor. You can build your own logic circuit in this field programmable gate array. Okay, so this is a universal circuit or universal chip where any of your or our logic control or logic circuit can be implemented. Okay, this is a bit complicated. Okay, but still in some devices FPGA is used. Okay, now single board computer. Single board computer means it's a complete computer but very small size. It consume very low power and we can use it in our in a number of robotic robots. Okay, so one is Raspberry Pi. Raspberry Pi, there are different versions of Raspberry Pi. Raspberry Pi Banana, Raspberry Pi 4, like this kind of different type of Raspberry Pi. And the recent Raspberry Pi also can run the AI programs. Okay, here is Raspberry Pi and Tinkerboard. Tinkerboard is also, these are a single board computer. And Little Panda, Jetson Nano become very powerful. Okay, it's a bit expensive. We bought in 14,000 taka maybe. It's a bit expensive, but surprisingly it can run AI programs. Okay, vision-based AI program. It also supports Raspberry Pi camera, that means Pi camera, and you can also some other web camera. But it can process the image. Okay, video image. Okay, and very efficiently it can process that image very efficiently. A number of program or a number of framework are available in GitHub. Okay, you can find it, you can implement in Jetson Nano. Okay, so Jetson Nano is becoming very popular for vision based or robot vision or vision-based robot in the current world. Okay, you can practice on it. I recommend some of you to use Jetson Nano for your robots. Then Intel NUC PC or Bricks PC. These are very small size computer, just like a computer. Okay, but very small size. Okay, so these are not so cheap. Okay, these are expensive but durable. Okay, we are using one NUC PC for 4 years with our Mongol 3 and still it's working properly. And then the last thing is cloud computing infrastructure. That means this is not a computer, this is not a PC, okay, but it's an infrastructure, a data center, or you can say the processing center. So we just receive, or by using IoT device, we are receiving data, we are sensing the environment, we are sending that data to the cloud, and the cloud is processing that things and giving us the decision. Okay, so cloud computing infrastructure is another interesting or another very important infrastructure for processing, okay, for control system, and of course our regular PC. Now these are the these are few projects we can proud to be, okay, BRAC University project. One is Chandrabot project, another one is Mongol 3, another one is BRAC Duburi, and there is another project which one is made by Pritam and Shakim, which is brain control wheelchair. Okay, I think these are our signature projects. Chandrabot, Mongol 3, these are made for a competition. Also, BRAC Duburi also made for international competition. You know, NASA is arranging competition regularly, so our Chandrabot was built for that. And Mars Society is arranging another University Robot Challenge every year. So currently we are going to that competition every year. Okay, so that is the one. And the Duburi project is built for another competition in Singapore, which is called Singapore Autonomous Underwater Vehicle Championship. So this robot is built for that. And brain control wheelchair is not for any competition. It was our own project. Okay, so by using emotive epoch, Pritam and Shakim, they could control the wheelchair. Okay. So yes, that is our BRAC on Nesha. These are the, now I would like to show you some latest technology, latest or the technology that are currently going under research. Okay, the extensive research is happening. So one is self-driving car. Uber is trying to make some self-driving car. That is one example. Then autonomous docking. I think this is also another very, very interesting autonomous task. Okay, one rocket is automatically docking with another rocket or another part of International Space Station. So this is the autonomous task. Okay, both of them are communicating each other and they are docking. Okay, each docking together. Okay, so this is a very, very interesting research or interesting application in robotics. Okay, then the Perseverance. I am happy to say now that Perseverance is landed successfully on Mars. Okay, when I am recording this lecture, I knew Perseverance is landed successfully. Okay, on Mars land. So that is the Perseverance rover. I think Kafi will discuss about this rover in details. That is another interesting robot, Roomba, which is commonly used in the home. Okay, in USA, Bangladesh. In Bangladesh, this is not so popular, but in USA or in Japan, Roomba is very popular for cleaning the floor. Okay, and in Boston Dynamics, they have built these robots. My favorite robots. One is Spot Mini, Spot, Atlas, and Handle. Okay, these are the robot made by Boston Dynamics. Please watch these robots on internet. Okay, go to YouTube, write the name of that robots, and you will see their surprising activities. Okay, and Da Vinci. Okay, the Da Vinci is robot for surgical. Okay, surgical robot. Okay, so one doctor can perform the surgery from a remote. Okay, so that is another very, how to say, another latest or very recent invention of robotics. Okay, so that's all for today. Thank you for watching the whole lecture with patience.